All right, let's get right into calculating cured-in-place pipe liner thickness.
Okay, so picture this. We've got an old pipe 8 feet down, and it's starting to fail.
The big question is, how do you fix it without digging everything up? What's the plan?
The solution is a new seamless liner, using a method called CIPP.
But for this to work, one number is absolutely critical. How thick does that liner need to be?
So here's our case file. These are the key engineering specs we're working with for this pipe. First things first, we check the book. The standard tables give us a starting point, right? And that base value comes out to 0.34 inches. Simple enough.
Okay, looks easy. So are we all done here?
Well, not quite. See, old pipes in the real world, they're just not perfectly round.
We call this deformation ovality, and trust me, it's a huge factor in our math.
When we actually measure this pipe, its ovality is 3.75%.
And here's the catch. The standard tables assume 2%. Our pipe is way more deformed.
That gap means we can't just use the book value. We have to do a proper calculation.
So, we break out the design formula. It's really just a simple 3-step process.
Once we plug in our real-world numbers, we get 0.362 inches.
So let's compare. Our adjusted design is thicker, and that's to handle that extra ovality.
Okay, but engineering is global, right? So let's switch this over to the metric system.
Here's how those key numbers look when you convert them from Imperial to MKS units.
So our final answer, 0.36 inches, becomes 9.2 millimeters.
And there it is, 9.2 millimeters. That's the magic number for a long-lasting fix. So that thickness handles the pressure today. But what about 50 years from now? How do we guarantee that?